Okay, so we are going to look at the problem that reads, a plane is at an altitude of 4,000 meters and flying upward at an angle of 37 degrees when it runs out of fuel. Oh! It's headed towards a mountain 4,450 meters tall and 1,440 meters ahead. If the plane has a velocity of 150 meters per second when it runs out of fuel, will it clear the peak or will everyone crash into the mountain? All right, so how are we going to solve this problem? Well, we're interested in the airplane. So that is our object. And what begins and ends the motion that we care about? Well, we start caring when he runs out of fuel. That's when things get a little exciting. And we stop caring when we reach the location of the peak. For some of us on the plane, maybe we really stop caring then. Okay, so we reach the location of the peak is sort of where we're done caring about the problem. So we have a single object, single acceleration, we're in a state of free fall, and two-dimensional motion. So we're moving through the air both horizontally and vertically. So let's draw our picture. Here's our plane, and here's our mountain. Now, it tells us that the plane is at an altitude of 4,000 meters, and the mountain has a peak at 4,450. When we define the world, we want to make it convenient for us, problem solving. So we get to choose where the 0 point is, and I'm going to suggest that our vertical 0 is at the plane. So everything above is positive and everything below is negative. But if our vertical 0 is at the plane, our position of the peak then is 450 meters. So the difference between where the plane is and where the peak is, if our 0 is at the peak. That might make problem solving a little bit easier. We also have to define the horizontal position of 0. So the origin there, and just as a reminder, everything to the right is positive and to the left is negative, so this then has a position of 1,440 meters in the horizontal direction. All right. Now we are told that the plane is flying with a velocity equal to 150 meters per second at an angle of, 37 degrees. Well, that tells us that it has both velocity in the horizontal direction and in the vertical direction when it runs out of fuel. So we can use our trigonometry to get the velocity in each one of those directions. So our velocity in the horizontal direction, and it's our initial velocity in the horizontal direction, is going to be 150 times the cosine, the adjacent, of 37 degrees. So our initial velocity in the horizontal direction is equal to 119.8 meters per second. And we also have an initial velocity in the vertical direction, and that's going to equal 150 times the sine of 37 degrees. And that's 90.3 meters per second. All right, so those are our two velocities when the plane runs out of gas in the two independent directions. So let's make our list for both our horizontal dimension and our vertical dimension so we can discover whether or not we're in trouble on this plane. So x initial horizontal, x final horizontal, v initial horizontal, v final horizontal, acceleration horizontal, and time. So thinking about each one of those players, each time, v initial vertical, v final vertical, acceleration vertical, and time. All right, so our initial position horizontally when he runs out of gas, well, we said that was 0. We're interested in how high he is at the point he's at 1,440 meters. So when he reaches the location of the peak. So we do know his final position based on how we've decided to identify this problem. Okay, so we're interested in what is happening if he is at that location in space. Now maybe he never gets to that. Maybe he crashes before the peak. Then the problem would be unsolvable given this information because it never gets to that point. But if we look at what he's doing at that point, if it does get to that point, it'll give us information about where he is. All right, our V initial horizontal we said was 119.8. We know there's no acceleration horizontally, so that meters per second. So our final is the same as our initial, and our acceleration is 0, and we don't know the time. All right, vertically, well, we are saying he starts at 0 meters. We don't know where he ends. We're interested in knowing where he ends. That's going to become our variable of interest, but we don't know if he's at the peak at this point in time. So that is our unknown. Our initial vertical velocity is 90.3 meters per second. We don't know our final. We do know we're in a state of free fall, so we're accelerating at negative 9.8 meters per second, and we don't know our time. So I alluded to what we're interested in, that being our final position. How high is he when we get to the location of the peak? If he's higher than 450, we're golden. If he's not, not so much. All right, so how high is he when he's there? Well, that's our variable of interest, so that's x final. And we're going to use the relationship for x final that we often use. X final vertical is what we're interested in. He starts at 0. He has a 90.3 times time plus 1/2 negative 9.8 times time squared. I need time in order to solve this problem. All right, I can't solve it without time, so I'm going to go after time. And time, well, I'm generally not going to get it from the same dimensions, so we're going to look in the horizontal dimension. So x final, again, I'll just put this equation up here. It's good practice to keep writing it so you don't forget these little nuances like the square. It's often forgotten, sometimes getting quick and being a little sloppy. So it's always good to practice. Besides, then you start to learn them easier. All right, x final is 1440. X initial is 0. V initial of 119.8 times t plus 1/2, of course, my 0, t squared. So that term goes away. And I'm left with 1440 is equal to 119.8 t. So time is equal to 12.0 seconds. Ooh, long time to see if you're going to crash or not. All right, let's plug that time into that value. It can join both of those lists. And we end up with x final vertical is equal to 90.3 times my time of 12 plus 1/2 negative 9.8 times 12 squared. And I get my final position vertically at the time we are at the peak. 12 times 12 is 378 meters. Oh, crash. All right, so once I get to that 1440, I am not high enough to clear the peak. All right, so recognizing our two-dimensional motion again, but in this case we had motion both in the vertical and the horizontal to begin with, so both of our dimensions have initial velocity that we have to consider. All right, good job.